We can also use vectors to solve word problems and prove math properties. In example number 6, a boat travels 80 km per hour, 45 degrees east of north, with the current pushing the boat 40 km per hour, 30 degrees south of east. Find the resulting vector in component form and in magnitude angle form. So here is my boat. This boat is moving 45 degrees east of north. So technically, starting from the north, you are moving to the east by 45 degrees. This is what it means by east of north. This boat is going 80 km per hour. So if I'm to make this graph bigger with 80 km per hour for this vector, I can consider this vector using the x component and the y component, which technically can be calculated using SOHCAHTOA. With 45 degrees here, then each side will give us 80 over root 2. Or in this case, 80 over root 2i and 80 over root 2j. So altogether, the boat is moving in this direction. Now when you think about it, if I am to calculate the magnitude of this vector, a squared plus b squared would give us c squared, which is the magnitude of this vector. So this is only for the boat. When it has the current pushing the boat 40 km per hour south of east, which means starting from the east, the current is pushing in the direction going to south by 30 degrees. And that means making it into the x component and y component. This line and that line here with 40 degrees in this case, right triangle, SOHCAHTOA, we will have this being 20j with a negative, and on the other side this would be 20 root 3i. So in this case, for the current, 20 root 3i minus 20j, combining the two vectors using the boat vector and the current vector, we can then come up with the resulting velocity vector. We can simply add these two vectors together, therefore giving us 80 over root 2 plus 20 root 3 for the I component, and for the J component, it starts from 80 over root 2 minus 20j. So this will be the component form. And for the magnitude form, magnitude angle, if we are having a vector moving in this direction for the x, with this for the length, and that for the right directions here, then I can assume that this will be the length on the y-axis, or for the vertical component, and here the horizontal component would involve this. So using Pythagorean theorem, a squared plus b squared equals c squared. That's the magnitude. And I can also calculate the angle in this triangle using tangent, inverse tangent with opposite over adjacent. So in this case, if I can use my calculator to find this, let me bring this graph from the calculator here. I will have 80 divided by square root 2 plus 20 root 3, and the square of this plus 80 divided by root 2 minus 20, close bracket, and square again. This whole thing will give us a squared plus b squared. And taking the square root of this, oops, taking the square root of answer will give us 98.267. 98.267 kilometer per hour. And for the angle, it is inverse tangent of 80 divided by root 2 minus 20. This is the first part, and I'm going to have this opposite divided by the adjacent. So I need another bracket here. Divided by 80 divided by root 2 plus 20 root 3. Close my bracket for the entire inverse 10. 21.8 degree. 21.8. And this will be north of east.